In the quiet countryside of Fleet, Hampshire, during the pivotal year of 1943, a machine emerged from the workshops of county commercial cars that defied every established convention of armored warfare. To the casual observer, it appeared less like a piece of military hardware and more like a prop rejected from a science fiction serial, a mechanical oddity that seemed to have no place alongside the rugged, utilitarian tanks rolling off assembly lines in Detroit, Stalingrad, or the Midlands. This was a tracked vehicle that sat barely waist-high when in its traveling position, yet it possessed a secret, articulated capability that allowed it to transform instantly. At the pull of a lever, a long armored box mounted on the chassis would detach and rise, driven by hydraulic arms, ascending 11.5 feet into the air like the rearing neck of a prehistoric beast or the predatory insect for which it was named. This was the Praying Mantis, a machine born from a brilliant tactical insight, but doomed by the technological limitations of its era, representing one of the most eccentric chapters in the history of British military engineering. The origins of this peculiar machine lay not in the fevered atmosphere of World War II, but in the muddy, blood-soaked trenches of the First World War. Ernest James Tapp, the man who would eventually conceive the Praying Mantis, served as a machine gunner during the Great War, an experience that etched a singular, terrifying problem into his mind. Tapp learned firsthand that to be effective, a machine gunner had to see the enemy, but to see the enemy, the gunner had to expose himself to return fire. Whether peering over a parapet, a hedge, or a stone wall, the act of acquiring a target necessitated presenting one's head and shoulders to lethal danger. Throughout the 1920s and 30s, long after the armistice, Tapp wrestled with this geometric dilemma of infantry combat: how to gain the height necessary to dominate the battlefield without offering a silhouette for the enemy to destroy. He realized that the solution lay in separating the eyes and the weapon from the vulnerable body of the soldier, a concept that would drive him to create one of the most unusual vehicles ever tested by the British War Office. Tapp was not a standard defense contractor, nor was he part of the military establishment's design bureaus. He was a commercial engineer who, along with his brother Percy, had founded County Commercial Cars Limited in 1929. Their business in Balham, southwest London, and later in Fleet, was primarily focused on the civilian sector, specifically the conversion of Ford trucks from 2 axles to 3 to increase load capacity. However, the looming threat of war in the late 1930s turned many industrial minds toward martial applications, and Tapp was no exception. He funded the development of his concept entirely as a private venture, convinced that he could sell the War Office on a solution to the problem of hull-down firing. His idea was theoretically elegant: a low-profile vehicle that could creep behind hedgerows, walls, and tall grass, completely invisible to the enemy, and then raise a hydraulic fighting compartment to fire over the obstacle before retracting and relocating. It was a strategy of shoot and scoot, integrated into the very mechanical architecture of the tank. By 1937, 2 years before Hitler invaded Poland, Tapp had patented his design, and by the outbreak of war in 1939, he had constructed his first prototype. This initial attempt was a one-man machine built on a custom chassis featuring Carden-Lloyd-type suspension, a design choice common in light carriers of the interwar period. The vehicle was a proof of concept aimed at answering a fundamental question: could a single soldier drive a tank, operate a hydraulic lift, aim weapons, and coordinate fire simultaneously? The War Office's response was swift and negative, rejecting the one-man design on the grounds that the cognitive load on a single crewman was simply too high. Driving an armored vehicle across rough terrain was a full-time job, Operating a complex elevating turret was another. Trying to do both at once was a recipe for disaster. However, crucially, the military did not reject the idea. They saw merit in the principle of an elevated firing platform and encouraged TAP to return with a two-man version, providing a rare validation for a private inventor in a world dominated by large industrial conglomerates. Encouraged by this feedback, TAP returned to his workshop to design the definitive version of his vision, the second prototype, which appeared in 1943. For this iteration, he made the shrewd engineering decision to abandon the custom chassis and instead utilize the universal carrier, widely known as the Bren gun carrier, as the foundation. This was the workhorse of the British Army, a vehicle produced in the tens of thousands, meaning that spare parts, maintenance knowledge, and manufacturing tooling were already ubiquitous. By grafting his revolutionary hydraulic superstructure onto this proven automotive base, TAP ensured that the vehicle would be mechanically reliable even if the combat concept was experimental. 9-liter power plant producing 85 horsepower, connected to a 4-speed gearbox and a standard commercial Ford rear axle. While the chassis and drivetrain were conventional, everything above the tracks was a radical departure from established armored design. The defining feature of the Praying Mantis was its articulated superstructure, a long, hollow armored box that housed the two-man crew in a prone position. The driver and gunner lay face down, head to head, inside this metal coffin, with their feet toward the rear of the vehicle where the hydraulic mechanism was anchored. This pivot point allowed the entire crew compartment to be raised from a horizontal position to a 55-degree angle, hoisting the machine gun turret at the front to a height of 11.5 feet. The geometry was specifically calculated to allow the vehicle to hide behind the 4 to 6 foot walls and hedgerows common in the European countryside. 303 Bren light machine guns. This arrangement meant that while the chassis remained safely behind cover, the lethal end of the machine could peer over obstacles, spray fire at the enemy, and vanish back behind the wall. However, the transition from engineering drawings to physical reality revealed immediate and debilitating flaws. The first and most significant issue was the sheer physical difficulty of operating the machine. Because the crew had to fit inside a low-profile box to maintain the vehicle's stealth characteristics, they were forced to operate all controls while lying on their stomachs. For the driver, this meant manipulating the clutch, throttle, gear stick, and steering levers in a contorted, unnatural posture. For the gunner, it meant trying to traverse the turret, aim the weapons, and change the 30-round box magazines of the Bren guns without the leverage or freedom of movement afforded by a seated position. The internal ergonomics were a nightmare, turning simple tasks into exhausting feats of dexterity. The decision to use light armor, mere 6 to 9 millimeters of steel plate, was a necessary trade-off to keep the weight down for the hydraulic system, but it meant the crew was terribly vulnerable if they were ever caught exposed. The trials conducted in 1943 and 1944 exposed an even more visceral problem: motion sickness. The physics of the Praying Mantis worked against the human inner ear in a way that no one had fully anticipated. By placing the crew at the end of a long lever arm, the elevated fighting compartment, any small movement of the tracks on the ground was amplified into a violent sway at the top. Moving the vehicle with the pod elevated was described as inducing a sensation similar to being on a small boat in a storm. As the chassis bounced over ruts and bumps, the crew compartment oscillated wildly, causing severe disorientation and nausea. Test crews found themselves fighting the urge to vomit rather than fighting the enemy. Even when stationary, The hydraulic suspension had a natural give that made the platform float slightly, making precision aiming with the twin Bren guns exceptionally difficult. The Praying Mantis was a sniper that couldn't hold its breath, a firing platform that couldn't stop moving. Despite the brilliance of the concept, the execution was practically impossible with the technology of the 1940s. The War Office recognized that while the vehicle technically functioned, the hydraulics lifted, the engine ran, the guns fired, it was operationally useless. A crew that was carsick, cramped, and struggling to reach their controls could not be expected to survive on a dynamic battlefield. Furthermore, the tactical doctrine of 1944 had moved beyond the static trench warfare that had inspired Tapp's idea. The war was now one of movement and combined arms. The British Army, along with their American and Soviet allies, relied on massed firepower, artillery support, and air power to deal with dug-in enemies behind obstacles. If a German machine gun nest was behind a wall, the solution was not to peek over the wall with a complex hydraulic lift. The solution was to smash the wall with a high-explosive shell from a Sherman tank or call in a mortar strike. The comparison with other nations highlights the uniqueness of the British approach. The United States, with its immense industrial capacity, focused on reliability and standardization. American doctrine solved the problem of defilade through volume of fire and indirect artillery support. There is no evidence that the U.S. military ever seriously considered the Praying Mantis for adoption. Their philosophy was antithetical to such specialized, finicky machines. Similarly, the Germans, who were certainly prone to their own wonder weapon experiments, never attempted a direct equivalent to the elevated crude platform. The Germans solved the height problem with periscopes and remote optics on assault guns, or simply by using the raw power of the 88mm gun to obliterate cover. The Praying Mantis stood alone as a uniquely British attempt to solve a universal tactical problem through mechanical eccentricity, fitting into a lineage of experimental vehicles like the massive Tog tanks and the specialized funnies of the 79th Armored Division. By 1944, the project was officially abandoned. The first prototype was scrapped, its metal likely recycled into more conventional weapons of war. The second prototype, however, was spared the cutting torch and eventually found its way to the Tank Museum in Bovington, Dorset. There it remains to this day, often cited as the strangest vehicle in the entire collection. What makes the survival of the Mantis so poignant is that its hydraulic joints are still functional. The quality of Tapp's engineering was such that, decades later, the machine can still perform its signature trick, rising up on its legs to peer over the heads of museum visitors. Tapp identified a genuine need, the ability to fire from defilade, but he was hamstrung by the requirement to put the men inside the gun. History, however, would eventually vindicate Ernest Tapp's logic, if not his specific machine. In the decades following World War II, as technology advanced, military designers returned to the exact principle that the Praying Mantis had pioneered. The arrival of guided anti-tank missiles in the 1950s changed the equation. Suddenly, a single shot could destroy a tank, justifying the complexity of a pop-up launcher. The direct successor to the Mantis was the FV-1620 Humber Hornet, developed in the 1950s for British and Australian airborne forces. The Hornet used a similar hydraulic boom to raise two Malkara anti-tank missiles above cover, but it solved the Mantis's fatal flaws. Crucially, the crew remained safely inside the hull while only the weapon rose, and the missile's guidance system eliminated the need for the stable platform required by machine guns. The motion sickness and vulnerability issues were resolved by separating the man from the mechanism. The legacy of the Praying Mantis extends even further into the modern era. Today, the concept of elevation plus protection is a cornerstone of armored vehicle design. The U.S. Army's M1134 Stryker anti-tank guided missile vehicle utilizes an elevated mast to fire tow missiles from behind cover, a direct doctrinal descendant of TAP's 1937 patent. Furthermore, the proliferation of remote weapon stations, RWS, on modern tanks and infantry fighting vehicles validates TAP's core insight. These systems allow gunners to sit deep inside the armored belly of a vehicle, viewing the battlefield through screens, while the gun operates exposed on the roof. TAP's only error was that he lived in an age of mechanical linkages rather than digital feeds. He tried to elevate the man to the gun because he had no way to bring the gun's view down to the man. Ernest James Tapp passed away around 964, living just long enough to see the Humber Hornet enter service, though it is unknown if he ever connected that vehicle's success to his own earlier struggles. His company, County Commercial Cars, continued to operate for decades, returning to its roots in agricultural and industrial conversions, drifting away from the world of experimental armor. But the strange tracked insect he built remains a powerful symbol of the experimental spirit. It represents the necessary failures that pave the way for future successes. In military development, as in science, a negative result is still a result. The Praying Mantis proved that placing a crew in an elevated pod was a dead end, forcing subsequent designers to look for ways to elevate the weapon alone. The vehicle sitting at Bovington is more than just a curiosity or a punchline about British eccentricity. It is a monument to the difficulty of innovation. To look at the Praying Mantis today, with its twin Bren guns pointing forward and its awkward, swaying gait, is to see a physical manifestation of a transitional moment in warfare. It sits at the intersection of WWII trench tacticians and Cold War missile technology. It was a bridge that couldn't quite reach the other side, collapsing under its own weight and complexity. Yet the existence of the Stryker, the Hornet, and every modern remote turret suggests that while the Praying Mantis was a failure, Ernest Tapp was a visionary. He asked the right question. He just didn't have the microchips, sensors, and guided munitions to build the right answer. The absurdity of the machine was real, but so was the genius behind it.